Welcome back. We are continuing our discussion on calculus, where we are looking at example number 2 under differentiation by the formula. So we have a question: y is equal to 3x squared minus 4x plus 6. We have to differentiate by the formula. We know the formula says given y is equal to ax power n, then dy dx is equal to nax power n minus 1. So basically, when you analyze the formula looks at one term alone. But when you compare the formula to the question that we have, the question that we have has 3 terms. We have 3x squared, negative 4x, and 6. So basically those are 3 terms. But the formula method of differentiation is defined on one term. So basically the way we have to handle such questions, we need to apply the formula method on each one of the terms that we are given, no matter how many they are. So because in our latest question, there are 3 terms, so we are going to apply the formula on each one of the 3 terms. So let's apply the formula. So we say solutions y is equal to 3x squared minus 4x plus 6. dy dx is equal to, so according to the formula method for differentiation, we need to identify our power n on each term that we are differentiating at that particular moment. So we need to identify the power n and the coefficient a. So we have n as the power of particular term, and we have a as the coefficient. So here, when you look at the first term here, n is 2 and a is 3. So we need to say na. So we say 2 times 3, where we get 6 x power 2. Now you can see from the power, a minus 1 has been subtracted. So we say 2 minus 1. Minus, we continue here again. We continue on the next term. You can see the way this term is negative 4x. 4 is raised to the power 1. Now, when a number, when a letter or a variable is raised to the power 1, we don't write that power on that variable because it is already 1. So that's why we have 4x without the 1. But when we are working out as we are doing, we reintroduce the power 1 so that it is visible in our calculations. So we have minus 4x power 1. So you can see our n is 1 and our a is negative 4. So we say na, so 1 times negative 4, we are going to get negative 4. Then the x will be maintained, and the power will reduce by 1. You can see the power was 1, it will reduce by 1. Okay? Then on the next one, we can simply write a 0. We can simply write a 0. Because actually, there is a rule which says the derivative of a constant is 0. Derivative of a constant is 0. So you can see C is a constant. It has no variable. C is a constant. It has no variable. So when a number is not variable, its derivative is 0. So we don't need to waste time here. So the derivative of 6 is 0. The derivative of this is this. The derivative of this is this. So that's why I said earlier that we need to apply the formula on each and every one of the terms. So we have applied the formula everywhere there, so that our final answer would be dy dx is equal to 6x. You can see 2 minus 1 is 1. But we shall not write a 1 here, as I alluded to earlier. Why we are not going to do that? Minus 4x power 1 minus 1, it is x power 0. I will not say plus 0 because it is already plus 0. It means there is nothing here. Okay, so now there is another step here to go where we have dy dx is equal to 6x minus. Now, look at this. Any number which has a power 0, the result is always 1. I hope you remember this law of indices which says so. Any number which has a power 0, the result is 1. So now, which number here, which letter has been raised to the power 0? It is actually x. This power 0 is only on x. It is not on 4. It is only on x. So it is the x power 0 that will give us a 1 here. So that our final answer will be dy dx is equal to 6x minus 4. So this is our derivative of y is equal to 3x squared minus 4x plus 6. Thank you.